All right. So why is it cool? I don't know why this is taking forever to do this. All right. Systems of equations and lines. 3.1. So I planned for this day to take this lesson take 2 days. If it takes 1.5, I would be happy because then that gives you half a class period to work on homework. That would be great. But I don't want to rush you. But yeah, so starting from like ground level, what is a system of equation? It's literally 2 or more equations. So one example is y equals 2x plus 3 and y equals 3x plus 1. That's a system. It's literally 2 equations. And if the solution is going to be the ordered pair, that represents the intersection of these 2 lines, and it satisfies both equations, meaning I have an xy pair that I could plug into the first one and the second one, and they both work.
Yeah.
So a system of linear equations can have no solution, they don't intersect. I can have one solution, one place they intersect, or infinite solutions, so they totally overlap. So if they have no solution, they're parallel, like 2 train tracks, right? Parallel lines, they never intersect. So if you have no solution, literally parallel lines. If you have one solution, they just cross. That's fine. Infinite solution is literally, they are on top of each other. They are the same line. Infinite solutions, any x could satisfy the equation.
And then 0 is like up and down.
What?
And then 0.
0 what?
Oh.
No. So there's 3 things. Either no solution, where they're parallel, one solution, where they cross, or infinite solutions, where they're the same line. Do you see how you can't even see my second arm?
Yeah.
Same line, no solutions, one solution. Okay.
Oh, yeah.
Visual. Here we go. So how do we solve by graphing? You graph both lines, you see where they intersect. Easy peasy. We've been graphing for a while now.
We have to get it.
That would probably be easiest. So let's change this first one into slope-intercept form. Oh my god. Don't say this is dead now. No, it's not. Okay. So let's change this first one into slope-intercept form. So I have x equals 2y, because I add 2 on both sides. Add 2y.
No, I did like minus x on both sides, and then I divided by
negative 2. Yeah, we get the same answer. It's fine.
Well, I was doing for y. Like, I got y equals negative 1 over 2x.
That's what I'm going to get as well.
Oh, okay. I you don't.
Nope. Do you see me trying to get my battery to work? That's probably the dumbest thing I've heard all day.
That's funny.
Like, I'm not even going to entertain this. Okay, I'll be right back. I'm going to get a... Okay, cool. New battery works. So I add 2y on both sides. Now I divide by 2. So I have 1/2 x equals y. So I can go and graph this. What is the y-intercept? 0. My slope is 1/2. Rise 1, run 2. Rise 1, run 2.
Isn't it negative 1 half?
Nope. I could do it the opposite way. So you said you subtracted x?
Yeah, so I subtracted.
So you have
x
negative
divided
2y
by
equals negative x.
So
Divide by negative 2. So I have y. And then you have negative x over negative 2. Negatives cancel out. And you have x over 2, which is just 1/2 x. X over 2 is the same thing as saying 1/2 x. Okay, so I just need to connect them. You need a straight edge. So when I'm looking at your graphs, this is a linear function, which means it should be a line. I shouldn't have any curves on your graph when I'm looking at your homework.
So you want
Cool.
3 dots? Like one?
Well, I just use that so I could easily use my arrows.
Oh.
Because it's really hard to have a ruler and draw straight on my surface. You have a pencil, you have a ruler. Super easy for you. Because your paper doesn't zoom in when you touch it. Okay.
Yeah, what if it's like they don't connect on the graph, but then you can tell that they're going to mirror?
So I wouldn't ask you a question for like solutions by graphing if it's gonna be off the graph. I try to make sure it's definitely on. Okay, so let's finish this one. So I'm gonna subtract x from both sides. Let me pick a different color. How about blue? Subtract x from both sides. So I have y equals negative x plus 6.
If it's like a...
So let me finish graphing, then I'll answer your question. So the y-intercept is 6. So I go to 0, 6, and I make a dot. And the slope is -1, because I have a negative x. That's literally a -1x, so down 1, right 1, down 1, right 1, down 1, right 1. So we see they're definitely going to connect on the graph. So I'm going to use my straight edge. Can you guys see the blue arrow? We see they overlap. What is the point where they overlap?
Wait,
One solution.
Put 2 the second.
How did I get the
3.
2?
4, 3.
Wait.
Oh, I didn't see that.
Okay, so we said 4, 2?
3.
2. That is the solution. The solution is where they overlap. So 1, 2, 3, 4, up 2. Yeah, so over 4, up 2. That's the solution. You just solved your first system of equations. So if I would plug in 4 for x and 2 for y, both equations would be true. So I'm just going to show you this. I'm only going to do it once. 4 minus 2, well, the y was 2, equals 0. So that's just 4 minus 4 equals 0. So that's true. I'm literally plugging them into the equation. 4 plus 2 equals 6. 6 equals 6. That's true. So I'm plugging in for x, I plug 4. In for y, I put 2. And I'm checking. Look, this solution, the 4, 2, when I plug it into here, it rings true. Do you see how I plugged it in and it actually matches up? Yes?
Mm-hmm.
Yes? No? I want to make sure we see it. Okay, cool. All right, Isabella.
So, really quick question. So, where it was like y equals negative x plus 6, say it was like negative x like over 2, how would you...
Negative, so it's negative 1/2. So down 1 over 2, down 1 over 2.
So is it always just the, what's the opposite of the denominator? You know,
So negative x over 2 would
yeah,
literally just be
but-
negative 1/2 x.
But how do you know which number is like the negative, like... in
So-
1 and 2?
If you have a negative slope, you know it's going to be going down from left to right, so the y would be negative.
So it's
Because we always,
going
when we graph slope, we always have our run be positive. We're always going left to right. So if you have a negative slope, you're going to be going down, so you make your y go down.
Oh, so run is always positive.
Yeah, when we're graphing.
Okay.
It just helps, makes it easier. Okay, so calculator skills. How do we find the solution? In our graphing calculator, we enter both of them. Analyze, intersection. Okay, cool. So let me open this up and I will show you how to do it. Oh my gosh. All right, so TI. So have your calculator out if you don't already. Go ahead, turn it on. So I'm going to show you how to literally graph 2 lines and find the intersection. So we had lots of practice putting in equations into our calculator already. So we're going to put these 2 in and we're going to double check our work that this is the actual solution. All right, so the press a test.
Yeah. Wait,
Okay, we can take it off in a second. I think this should work.
how do I switch it back to FX because it's on?
Relation,
Yeah.
menu, graph, entry, edit, function. Okay, so the first one I want to enter is, what was the first graph? Sorry. X minus 2y. So I have, so we moved it around, so we said 1/2 x. So I put in 1 divided by 2x. Push enter, I have 1/2 x. That looks like what we did. Oh, gotta push tab so I can put in my second one. Negative. So notice I have to put the minus, right? The negative. Do you see where I selected the negative? It's not subtractions. What? Push tab and you have to delete the previous functions. So I have negative x plus 6. Enter. Okay, so I see they intersect. What I have to do, well, I'll wait till we all have this on our calculator.
When I press this is
So I just push enter.
when I press that, like once I typed it in.
Right now you just have f1 of x.
Yeah, but.
So you need to have 1/2 x. So 1 divided by 2. Scroll down, and our second one is going to be negative x plus 6 enter.
No, x equals.
No, I did not. I just put 1/2 x. Alright, if your calculator does not look like this, stretch your hand. Okay. So, nope. I don't, okay, so you're here. Now you just put in 1/2 x. 1 divided by 2x. Nope. What? You don't need that. Okay, do it anyway. 1 divided by 2x. 1 divided by 2x. Push the down arrow.
1/2
Down arrow.
x.
Okay. And now I want you to do negative x plus 6.
No, just divide those. 6. It's just after x equals.
Perfect. Alright, everyone help me out the second one? Negative x plus 6. Cool. Anyone else not have both of them? Okay. So now that we have that, how do I find the intersection? So you push menu, analyze graph. Menu, analyze graph. Menu, analyze graph, and then guess what? We're going to click intersection. So I don't want you to click anything else. All I wanted you to do is want you to get to this point where it's like blinking. Lower bound, you go to the left of your intersection. Upper bound, you scroll and you go to the right, and it pops up your intersection. It tells you where this occurs.
Press anywhere and then drag to it.
So
Cool.
I'm going to go back. I'll do it again. So I click menu, analyze graph, intersection. So notice I have to go, it says lower bound. Do you see where it says lower bound on the left side? Left lower side, it says lower bound. So I have to scroll over, and then you click this middle button right here. You use this to scroll over, and you click where it has lower. And now you scroll over to where you go to the right of the intersection. Scroll over to the right, and you know you did it correct when it pops up and it says intersection. So then you click, and it will pop up the intersection for your graphs. Perfect. This is a good way to double check your work.
What do you have to push on the calculator to bring up those do the straight lines, parentheses, the ones that make them positive? What are they called?
Absolute value?
Absolute value. How do you
The math template key, which is to the right of the number 9 button. Do you see where
Okay.
It's right there. Okay. So I was showing you how to do the intersection. Now that we know, you can always double check your work. Keep in mind, being very clear and upfront with you, when I ask you to graph, do you see how much work we did? Right? So mostly, I'm talking about this part right here, showing how I moved it into slope-intercept form. And then I see a couple dots on my graph. It shows me how I use the slope to graph my line. Notice it's not blank with just 2 lines. That's wrong. I want to see work, because what happens if you graph it wrong? I want to give you as much credit as possible, but I have to see your thought process. So you have to show work. You don't need this part under here. I was just proving to you the fact that this coordinate works for both of my equations. And if you forget, here is the literally directions right here on how to find the solution. Okay, this is what I was talking about earlier. Linear systems, this has one solution. Here, this is infinitely many solutions because it's the same line, but it's overlapped, so infinitely many solutions. And notice it says infinitely many solutions. Versus, if they are parallel, they will never touch, there's no solution.
Is there a sign for infinitely many, or do you just put the
Infinitely
R,
many.
R? You put the R?
Use write infinitely many solutions. For no solution, you can put this, but infinitely many, you must put infinitely many. Okay. But look, I even write it, no solution, one solution, infinitely many. So I write it out for you, so that way you know how to spell it and you can write it. Alright, if the solution has one solution, name it. So what we're going to do is graph this. And notice I have the A in slope-intercept form. So for the first one, does someone want to come up here and graph it for me? No? No participation points? That's fine. Okay, y equals...
Me.
It's too late. It's too late. All right, y equals negative x plus 8, so I go up to 8. Make a dot. Negative x, wait, so that's a negative 1 slope, so down 1 over 1. Down 1 over 1. Down 1 to the right 1. Down 1 to the right 1. Okay, I have plenty of points now. I can easily use my straight edge and connect them. Oh my god, that was a bad one. Okay, so there's my first one. How did I do this? Well, I see that this is my y-intercept. So you could say slope equals negative 1. Y-intercept is 8.
Isn't it negative 8? No,
No,
it's not. 'Cause
it's
the
not.
X goes over. Okay, never mind.
Alright, so if I look at this next one, I see slope is 4, and my y-intercept is negative 7. How much work did I just show?
A lot.
Enough to get credit, because by writing that out, imagine, you are not sitting with me when I grade your tests and quizzes and homework. But by literally pointing and saying m equals 4, that shows me you understand 4 is the slope. Cool. I'm not trying to be nitpicky and make you do all this work. All I want to know is, do you know how to do it? Show me you know how to do it. You just drawing the graphs. I don't know. Maybe your calculator did it for you. I want to know you know how to do it, not your calculator. Okay. Y-intercept negative 7. Slope 4. Up 4, 1, 2, 3, 4 over 1. Up 4, 1, 2, 3, 4 over 1. Up 4, 1, 2, 3, 4 over 1. Then I connect them with a straight edge. So what I just showed you on your calculator, you can use to double check your answers as you're going through this whole chapter, for at least the first section.
That would be one solution.
So this is, exactly. So it's one solution. And because it only intersects 1 point. And what is the, let's see, 1, 2, 3, 1, 2, 3, 4, 5. So 3, comma 5. Perfect.
Okay, next one.
Let's keep going. Let's keep going. Let's keep going. You only volunteer after I told you participation points. But you knew. You knew. But I realized, I want to, keep up the pace. Well, I counted over 3, up 5 to figure out what point that was.
You can also check.
Well, I just counted. Yeah, but you can check it on a calculator. All right, next. Here we go. So, let me rewrite this in slope-intercept form. So I have 2y. Oops. Do you have a question? Okay. So I have 2y equals negative x plus 5. I just subtracted x on both sides. Then I must divide every single term by 2. So that way I can get y by itself. So I have negative 1/2 x plus 5 halves. Okay, so 5 halves. That's the same as 2 and 1/2, yeah?
Oh, that's right.
So it's the same as 2.5, so I draw a dot at 2.5 because that's my y-intercept. And then I have a slope of negative 1/2. So down 1 to the right by 2. 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 So 5 halves is the same as 2 and 1/2. So it's at 1, 2, and 1/2. Yes.
I always get confused because since you're dividing by positive 2, doesn't it just make the whole thing negative, which would also make everything positive?
Since I'm dividing by,
Positive 2, the 1/2 wouldn't just.
no, because I have negative x, and so I have a negative divided by positive, so it stays negative. Right here, I have a negative. Oops.
Yeah, but then it makes the whole thing negative.
The slope would be negative. Cool, so I have this one. So next, let's see. Notice, is there a common factor on all 3 on my second equation?
2.
Is there a common factor? Okay, 2. So what if I divide everything by 2?
And then you simplify it.
Divide it all by 2, I have x plus 2y equals 1.
4. You can do.
What? You want to solve first and then divide by 4?
Yeah.
Okay. All right, Isabel, let's do it this way. So you could simplify it.
No, I do
What?
like that too.
Yeah,
Like
yeah,
minus
like-
2x minus 2x on the side.
yeah.
So I'll show you both ways, whatever. So I have 2y equals negative x plus 1. So this turns into y equals negative 1/2 x plus 1/2. Or, alternatively, what if we solve for y first? 4y equals negative 2x plus 2. This is, so literally start at the beginning again, subtracting 2x from both sides, getting 4y by itself. Divide by 4, we get negative 1/2 x plus 1/2. Because 4 over 2 is the same thing as 1 over 2, which is 1/2. Okay, so I have 1/2. So it's halfway between 0 and 1. And the slope is negative 1/2. So down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Ooh, interesting. Interesting. Maybe not. Maybe you don't see it. I don't know. I don't know.
It's
Okay.
parallel. That means that there is no solution.
Exactly. These are parallel. No solutions. You see these two lines? Parallel. They're literally train tracks. Never will cross. There's no solution. There's no point where they will cross. Wonderful. How do we feel about this so far? Okay. Just make sure everyone had time to write. So we're gonna do, okay, seems like we're doing pretty well. So I want you to try C and D. Try C and D yourself. So I'm gonna put the solutions on the two I crossed out. We're just gonna do C and D together, and then you can always look at E and F. So try C and D yourself. Infinitely many solutions. It's exactly what happens with C. It is the same line, so it's going to be infinitely many solutions. It's kind of hard to see. Let me make it a little bigger. Hopefully we can, hopefully on the screencast people can see this, and hopefully you can see they're the exact same line. So I'm going to edit the properties, literally see. Infinitely many solutions because they're the exact same line. So, I mean, honestly, this is what I want to show you. We did an example where there was one solution, did an example where there was no solution, did an example where there was infinitely many solutions. The rest, like, honestly, like, now that we've done an example of all, it's just graphing. Practice graphing. Can you graph? Okay. So, did you already do D? If you haven't already, give it a shot. Let me know if you have questions over what we've done so far. And remember, if they have 1 point of crossing, we're supposed to say where they cross.
For F, because
The first one, a -2. For the blue, it's a -2. So here we have 1 point of intersection. It's at 3, 1. One solution. Alright, questions over C and D? Okay, we can just do D and F. That's fine. Or E and F, and I'll just put them up again. It's good practice. Just do E and F. Leave it up here for another couple seconds or so. So if you're done with C and D, go ahead and try E and F. It's good practice. Can I move down? Oh, wait a sec. Don't want to rush you. Yeah, so for this first one over here, you had x minus y equals 2, so I added y on both sides. So I have x equals y plus 2, I subtract 2 from both sides, and then I get x minus 2 equals y. That's how I found this blue one. All right. So I rearranged the first equation, right? So I had x minus y equals 2. So at this step right here, I add y on both sides to get x equals y plus 2. Then I subtract 2 from both sides, and I get x minus 2 equals y. All right. Perfect. Give E and F a shot if you are ready. So I already have it in slope-intercept form, so it's pretty nice. So this top one, the y-intercept is -4, and the slope is 3. So go -4, up 1, up 3 over 1, up 3 over 1, rise of 3, run of 1, rise of 3, run of 1. So you only need 2 points. You only need 2 points. I'm just being, facetious. I'm doing like 50 just to show you what it looks like. And it makes it easier because I have these arrows I'm drawing, but you just need 2 points, then you connect them with your ruler. Okay, so here's the first one. The other one, slope of -3. Y-intercept of -4. So they have the same y-intercept. Difference is different slopes. So -3 slope, so down 3 to the right 1, down 3 to the right 1. Then I just connect them. Cool. So I see there is one solution. And where is it? 0, -4. Cool. Alright, so here I have x plus y equals 2. So it's just going to be y equals -x plus 2. I feel like we already did this one. So all I did was subtract x from both sides. Okay, that's the first one. The next one, oh, well, wait, it gives it to me. So y-intercept of 7, slope of 4, y-intercept of 7. So the slope would be right here, but I could go left 1, down 4, left 1, down 4, because guess what? That still is a slope of +4. And I see I have one solution. One solution. And it's going to be a -1, 3. Perfecto. Let's keep going. Alright, leave it up for about, I don't know, 5 more seconds. How are we feeling about this overall so far? Are we doing okay? Good review? Like, if you have questions, just think about it. Now's the time to ask. This is not an issue. Other people have probably the same question. It's better to ask right now than to not know it on a test. Because tests are worth a lot. So, cool. Alright, so okay, I think everyone's done. So, SAT practice. In the XY plane below, 2 lines intersect at the origin. Which of the following pairs of equations could represent these lines where A and B are positive constants? Okay, so what's the slope of the blue line? It's positive. What's the slope of the red line? Negative. So I know that I should have, and if I write it in y equals mx plus b, slope-intercept form, what's the b? What's the y-intercept? 0, because they intersected the origin. So I'm literally going to have 2 equations where I have y equals some positive number times x, and I'll have a y equals some negative number times x. Alright, so the positive number comes from the fact that the blue one has a positive slope, and this negative number comes from the fact that the red has a negative slope. So which one could it possibly be? B. That is the answer. What is wrong with answer choice A? They both have positive slopes. That's not what it's supposed to be. What is wrong with answer choice C? Both positive slope. Here, both negative slope. And we already looked at the graph. We said, wait, one should have a positive slope, one should have a negative. And what's wrong with D? This is literally parallel lines. Do we have parallel lines? No, these are parallel lines. And wait, what plus B? No, we said we don't have a y-intercept. Okay. More PSAT practice. Do you know when the PSAT you're taking it? If you're a junior? October 30th. That's right. We're going to get your math score up. Woo woo. We're working on it. We're working on it. All right. Each dot in the scatter plot below represents the temperature and number of people who visit a beach on one of 11 different days. The line of best fit for the data is also shown. The slope is 57. All right. According to the line of best fit, what is the number of people rounded to the nearest 10 predicted to visit this beach on a day with an average temperature of 32 Celsius? So where do I see 32 Celsius? How many people do you think it is? All right, think to yourself. Think to yourself. I'll give you 5 seconds to look at the graph. Okay, you have a number in your head. You literally read the graph. Now turn to the partner next to you and discuss what number you think it is. All right, Talia, you want to discuss with her? You want to discuss with her, and do you want to put your phone away?
Sounds like close to 5, 6. It shows it's between 31 and 32. It's almost at 560, so it's probably around 600.
So at 32 Celsius, 32 Celsius. Jesse is gone. Okay, what number do you think it should be? Thank you. All right, what number do we think it should be? So at 32 Celsius, 32 Celsius is right here. I go up to where I reach the line. All right, so 32 Celsius is right here. Where is the intersect? 480. 480 people. Okay. According to this estimate, how many additional people per day are predicted to visit the beach for each 5% increase in average temperature? Ooh, let's see. So, 32 degrees. What's 5 less than 32? 27. Let's look how many people are at 27. How many people are at 27? 200? Okay. So wait, if we had 480 at 32 degrees and we had 200 at 27, an increase of 5 degrees Celsius means an increase of how many people? 280 people. Because we go from 200 to 480 people when we go from 27 degrees to 32 degrees. So that's a difference of 280 people. Perfect. All right, so we are going to start, we're going to do some of the substitution, and then the next class we'll finish the substitution, we'll go through elimination. We still have like 15 minutes, solid. My goal, get through half the substitution stuff, and then we'll be sitting really good place. All right, so there's two methods of solving systems algebraically. What we just did was we graphed them and we saw where they intersect. Remember, there's three options. Either they intersect at one place, they don't intersect because they're parallel, or they're infinitely many solutions. So now we're going to look at what that looks like algebraically, literally solving, not just graphing, but solving. So substitution is the process of replacing one variable with something of equal value. So for example, if I have x equals 5, and I want to know what is 3x minus 8, you can literally substitute in 5 in for x, right? So we substitute in 5 for x and we go through and solve. Because those are equivalent statements. Those are equal. We can also use substitution to solve a system of equations. So I see y is equal to 2x. So if I plug that in for y, let's see what I get. X plus y, well, y is just 2x, equals 3. What is x plus 2x? 3x. So I have 3x equals 3. And how do I actually finally solve this? Divide by 3. So I get x equals 1. Those are the two things I heard you guys say. Now that I have x, wait, I'm trying to find a solution. And remember, a solution for a system of equations is a coordinate, an x, y coordinate. I have my x. What do I need to do? Find the y. How do I find y?
Y equals 2x.
Oh my god, beautiful. You literally plug it back in here. So I have y is equal to 2 times x, so it's equal to 2. So my solution is going to be 1, 2.
It will be x plus, be 1 plus y equals 3.
1 plus y equals 3. That is true. Oh, we could plug it in there. I just plugged it into the top one because then I didn't have to rearrange.
Oh, you can choose
So, so I could plug in 1 plus y equals 3. So I subtract 1 from both sides and I get the same answer. Awesome. You guys just did your first substitution of the year. Yay. All right, let's do another. Okay. Okay. That's fine.
It's like the quietest class.
No. Nah.
Really?
Not even close.
All thanks to
Well, you guys are doing a very good job. You are. Oh, sorry. Did I go too fast? You want me to zoom out? But you guys are doing a good job. Say for the most part, we're like pretty on it, being like engaged. All right, let's try the next one. Are we ready? Let's do it. So I see y equals 3x. So when you're doing substitution, if one of the variables does have a coefficient, so notice, what's the variable in front of this first y? What's the coefficient in front of the first y? 1, right? So if you get either x or y with a coefficient of 1, that's ideal, especially if we have it solved. So I see y equals 3x, so I'm going to plug this in for y. X plus 2 times, well, what did we say y was? Oh yeah, 3x equals negative 21. So I have x plus 6x equals negative 21. Must combine these. So remember, when we solve systems of equations, it is an x, y, a coordinate pair. I have x, now I must find y. So you have a choice. Either you could plug in to the second equation, or since I'm trying to solve for y, I'm going to plug into the equation that already has y by itself. So I'm going to plug this into y equals 3x. So this is 3 times, well, my x value was -3, so that gives me a y value of -9. So my solution is -3, -9. So I tend to do the thing that is easier. I don't want to do more work than necessary. Cool. Are we on the next page already, or are we good? Trying to make sure I don't go too fast. Are you on the next page?
Yeah.
Okay, I just want to make sure I don't want to rush you guys. Make sure we have it written down. Let the sauces and thoughts marinate and like really understand how do we do this. Okay, this next one. Which one do you want to use? Well, this is solve for y, right? So I could plug this whole thing in for y. We're using substitution to solve the system of equations, to solve for an xy pair. So I have 2x plus, remember I plugged this in for y, -4x plus 12 equals 2. Just going to rewrite it. So the reason I put parentheses when I first plug it in, what if this was like minus y instead? I don't want to lose the fact that if this was a negative right here, I would have to distribute it. That's why I use grouping symbols and parentheses. Grouping symbols are your best friend. Takes you 2 milliseconds to draw it, but it will save you in the long term. It'll save you in the long term. Don't make little silly mistakes that have nothing to do with math skills, all right? So we're trying to reduce the errors you make. Okay, so let's go ahead and let's combine these. 2x minus 4x is -2x. Okay, so -2x plus 12 equals 2. Gotta subtract 12 on both sides because I'm really trying to get x by itself. What I first did was I combined like terms with the purple curly Q. Combine like terms. Then I move the number to the other side. I still have -2x on the left side. Need to divide by -2 so I can get this x by itself. And now the trick part is -10 divided by -2, so a negative divided by negative is positive, so it's 5. And then we get to choose. I'm just going to plug into this first one right here. I'm just going to plug this in for x. It doesn't matter. You can plug it into either one. The only reason I'm plugging into the top one, because I already have y solved. If I just plug in, I'll find a number instead of having to like rearrange it. -4 times 5 plus 12. -20 plus 12 is -8. So our solution is 5, -8. Let me rewrite it so it's a little nicer. Perfecto. How are we feeling on this so far? Just like, just quick gauge. Yeah, good. No. It's also cool to be like, nah, it's fine. It's not like cool, but we have more examples. Okay. So far, I've had it solved for you. I've had like, oh, y equals this thing. Issue with D, I don't have it solved. But the trick with substitution is you look for the variable that has a coefficient of 1. What should I get by himself here? X. Let's get x by itself. Okay. So I'm going to rewrite this one as x equals 2y minus 3. Because I add 2y on both sides. Now that I have this, I can plug it in for x. What do I have to do with this 3? Distribute. Oh my god, on it. Point. Here we go. Beautiful. All right, we have to distribute. I like that vocab words you're using, literally math terms. All right, 6y minus 9 plus 5y equals 24. Now I have to this is so great. Okay, combine like terms. Okay, 11y minus 9 equals 24. Add 9 to both sides, because I'm trying to get y by himself. What did you get? Can I see what you did? So you have 3.3? Yeah, you got, well, let's see. That's so random. Yeah. Well, 3.3 works. But, like, I think it's just a fluke. I think it's only going to work on this one. It's not going to do general. You have to distribute the 3. That's just weird that it worked. Oh, yeah, sorry. We got to solve for x. So we have 2 times 3 minus 3. 6 minus 3. So it's literally 3.3 is your solution. If you haven't already, give it a nice little shot to work on this PSAT practice, if you haven't already. I don't know, I guess I'll have x be y plus 8, and then I'll use this to plug in for x. So it's just exactly what we've been doing, no surprise. I throw in questions that are similar to what we've been doing. And keep in mind, it's not just find the value of x and y. It wants the value of x plus y. 100%, you're going to have a problem just like this on the PSAT in about 2 weeks. They love these types of questions. They don't want to know what is x and y. They want to know what, when you add them, what do you get? Because notice, this is the x value. This is the y value. Yeah.
Wait, can't you not write on the PSAT?
I mean, they don't look at that. Your scratch paper, but they only look at your bubbles. So showing work there doesn't do anything, but you can mark up your SAT. Who told you couldn't? The school, because they think cheap. No.
Yeah, they tell you when you go in, or no, the EIS,
The PSAT?
To get into a school.
ICE? Yeah.
Wait, but it just gives you the answer right away.
What? Well,
X plus Y plus 4.
yeah, but a lot of times people are like, oh, find it, cool, I found 11. Or they'll find 3 right away and they'll stop there. That's the issue. Or they'll be like, oh, I found X. And notice they had both the X and the Y, but what they wanted was X plus Y. So the SAT is trying to trick you. When you take the PSAT or SAT this fall, they're going to try to trick you.
It's going to be more complicated.
Make sure you answer the question fully. What?
I took the ACT, and on that, it was like nothing. Like literally, I did pretty well because like I'm good at English, and it was like fine in that portion. But the math, it was really difficult for me because they gave it like where I was in like a lower classroom. Like I was in like geometry last year, and I took it. It's like the math is literally like it's crazy.
They don't give you calculus.
It's not like calculus, but it's
at the end,
a lot of really hard math. And I didn't finish it.
It's a lot of.
And I did like PACTs.
Yeah, so probably a lot of the math though is stuff we'll be learning this year.
Really?
Yeah, like the stuff you thought were calculus is trig. They test trig. They don't test pre-calculus or calculus. Yeah, because the whole reason the SAT and ACT exists is to try to have a level platform to base like where students are. Because if you look at someone from the middle of Nebraska, you have no clue if they're 4.0, how it compares to someone here's 4.0, you know? So it gives it like this standardized test. Because, like, I mean, even if you compare teachers among this school, an A for me is much, much different, much, much more work than an A for another person, probably. Right? So, like, letter grades, it's just a toss-up, right? Okay, so this is page 6. This is a good, pretty good place to stop because we have 1, 2, 3, 4, 5, like 7-ish pages to go over. But guess what? This is more about substitution, more practice substitution, right? So these first like 2 pages, it's just a little review. We'll hit elimination. Solid. All right. See you guys next week.